If you are currently leveling up your Django skills with this tutorial is part of a free YouTube playlist. The link to the whole playlist is in the video description. Now, if you love this tutorial and playlist, then you might also like to check out the whole course, Django Database ORM Mastery on Udemy. The link to the course, which should provide the best price, can be found in the video description. In the previous tutorial, we introduced the basic commands needed to create, manage, delete, assign new objects to schemas that we have created. For us to effectively work with schemas, we must understand the basics of the schema search path in PostgreSQL, which determines the order in which schemas are searched when you execute SQL queries that do not explicitly specify a schema. Simply put, when we run a query on our database, the Postgres database is going to look in a particular order at the schemas to match the query against tables and data that we're querying. So, as I mentioned, you can, when we run the query, actually specify the schema we want to use that query on. Now, if we don't do that, if we just run a query in Postgres database, behind the scenes, Postgres database is going to search through all of our schemas until it makes a match. And it's going to do that in a particular order. And that order, that's what we're describing as the schema search path. It's a list of all the schemas in a particular order where Postgres is going to work through one by one until it makes a match. So you can imagine here, if we run a query on our database, imagine we have, say, 4 schemas, and the order so far is this order. The query is simply just going to run on all of these different schemas until it makes a match and is able to run the query. So you can imagine if we had, for example, on schema 3, imagine we had a table for products on schema 3. So we run a query, so select all from, in this case, products. So what's obviously going to happen here is that PostgreSQL is going to simply look through schema 1 first, schema 2, schema 3, then makes a match, and then goes ahead and returns the data. In many cases, this approach isn't necessarily ideal, searching through multiple schemas. So we do have the capabilities to customize the schema search path. To manage the schema search path, generally we would configure this in 3 different ways. So first of all, we can set the schema path based upon the session. So we can set the search path at the session level using the set command. So we have a user. We have this user. They log into our Postgres system, and then that generates or creates a session. So at this point, we can go ahead and maybe in the terminal and use set, which we're doing it shortly. We go ahead and set the schema path, and that would then be applied at that session level. If the user were to disconnect and then come back again, they would potentially have to, if they create a new session, go ahead and set that again. Now we can also persist the search path at the database level permanently for the database, and for that we would simply use a different command, and for that we would use the alter command, and we'll do that shortly. So that's the second option. So we have a session option we have at the database level, and the third option will be user specific search paths. So this will allow us to set the search path for individual users. So here we set the search path for a specific user, and we can do that by utilizing the alter role command. So we have inadvertently answered the question, how does PostgreSQL know which database or which schema to select when we run a query? And the answer to that is that the search path is the reason that users can omit schema names when actually running SQL queries, which ultimately makes it easier and shorter to write SQL queries. Having the capabilities to alter and change search paths at the session database and particularly the user level really can enhance security by setting appropriate search paths and restricting users' access to specific parts of a database. Improved organization, so we can organize data objects into schemas and utilize this search path to maintain a clear, more logical structure within our database. Separation of concerns, which can also make it easy to manage and navigate large database. And also this reduced risk of naming conflicts. So the search path can help manage naming conflicts by specifying the order of schemas to search. So this ensures that objects with the same name in different schemas do not interfere potentially with each other. Now, if you're thinking about building a multi-tenant application, then this type of feature can be really useful to help you manage those tenants and access to the data. So the search path can allow the application to switch contexts easily to serve different tenants without changing the underlying SQL queries. So let's go back into InventoryDB and let's select our database and let's run the SQL command. So first of all, let's go ahead and show the search underscore path. So that should return the current search path. You can see here that there is one schema in the search path, and that is public. That, in fact, tells us that when we run queries as this user on the database, that is the only schema that's being checked here. So in order for us to actually run a SQL query on, for example, the information schema, we would have to explicitly define that when running SQL queries. That's what it's suggesting here because it's not in the search path. Now, if I were to just copy this and then at the top here, you would need to make sure this is matched. Just select inventory. So I'm just in the database inventory now. Let's run the SQL command again. In actual fact, this time you can see it returns user and then public. So where you can see user here, it's being used in the search path. PostgreSQL replaces it with the name of the current user. So for example, if the current user is Xander, then this user becomes Xander. So this allows each user to have a personal schema that matches their username, facilitating personalized database environments and avoiding conflicts with other objects. Or should I say, other users' objects. So I'm probably elongating this somewhat, but this essentially means that Postgres will first look for objects in the schema named after the current user, and then in the public schema. So what you have noticed is I've switched back to the schema public and run the show search path again. You'll see that the search path in PostgreSQL can vary when you interact with different schemas. Now, you might be wondering why, if we return back to the schema public inventory and run show search path, that the search path only returns public. What we need to remember here is that behind the scenes, we have selected the public schema. So in actual fact, this query is running on the public schema, and therefore the only schema that is viewed is the public schema. That's why we don't see the user component before here in the search path. So you just need to be careful to make sure that you run these commands in the correct place. So I'm going to deselect any schema here, run the commands without selecting the schema, but of course my database is selected. So let's go about changing the search path. Let's first of all execute that. So we have user and public. Now we do have some different schemas here. We created a schema here called inventory admin. So let's add that now in. So all we need to do, now here we're working at the session level. We're going to be utilizing set. So we're going to set the search path at the session level. So should I log out, log back in again, create a new session, then this won't be available. I'd need to set this again. So utilizing set, so we set the search path, and then we just need to define the search path. So let's go for public, we need a comma, and then let's go for inventory admin. So I'll go ahead and execute that. Looks like we have typed it out correctly. Let's now go ahead and show the search path again, and that obviously will be updated. Now you are expecting the actual table to be updated. What you need to remember here is that we're working on the session level. And in actual fact, this doesn't really have any relevance to this graphical user interface. But if we were, for example, utilizing the PostgreSQL command prompt, that would set it at the session level. So should we then go ahead and run a query, it's then going to utilize that particular specific search path setting. So let me just show you that in action. I have PostgreSQL server installed on my machine, which gives me access to the PSQL, which is the interactive terminal for working with Postgres database. So I can type in PSQL. I can then specify the host, local host, and then the port number, although this is the default port number, and then the user, Postgres, and then the actual database, which is inventory. Okay, so with that, I'm then asked for the password, which is Postgres. This is how we log into a Postgres database. And you can see I'm now inside, if you like, I'm working inside my Postgres database. So going back to the command we had previously, setting the search path to public and then inventory admin. So I'll go ahead and set that. Now remember here we're working at the session level. Go ahead and show search path. And you can see now in actual fact, I'm showing public and inventory admin. If I just go ahead and cycle, so I quit, and then we go back into the database. And let's try this again. So let's show the search path, and now it just states public. So we simply can't replicate sessions here with admin, and that's why we're not showing the search path changing when we utilize set. So let's make the change at the database level now. For that, we simply just need to alter the database, and that's the inventory database. We need to set the search path to public, and then we mentioned inventory admin, inventory underscore admin. Yep. Okay, so let's go ahead and change that. Looks like everything was okay. So now when we go ahead and show the search path, it has now changed. And then finally, setting the search paths for individual users, we simply need to just change for the user. So we alter the role. In this case, we don't necessarily have any users. So let's just imagine there was a user, Xander. We would set the search path, it's looking very familiar now, to, and then just go ahead and change the search path. So that's how we're going to set the search paths for individual users. Now, setting roles at the user level, if you've got thousands of users, hundreds of users, then that's not going to be the most productive way. Something we haven't mentioned yet, which we will cover later on, is roles. So we can actually apply search paths to individual roles. If you just think about roles at the moment as groups, so maybe we have this group called admin, we would then go ahead and assign our search path to this admin role, and then we would apply this admin role to many different users. And of course, they would inherit the search path from the role. That, of course, just makes it easier to assign search paths to different users. So then to summarize, in PostgreSQL, the search path is a list of schemas that determine the order in which database objects being tables, functions, and views, are searched when executing SQL queries. Now, in our examples, we really only have been talking about tables, but we can manage tables and schemas like we would do functions and views, although we haven't formally introduced functions and views necessarily. These are just objects, things that we can store in the database and utilize, resources that we can utilize and manage like tables, applying them or assigning them to different schemas. So in this tutorial, we've learned that we can customize the search path at the session level, at the database level, at the user and role level. And by doing this, it allows for greater manageability and organization. This ultimately ensures that queries run in a predictable context, reducing any conflicts or issues that might occur should we not have the specific ordering in place.